Hello everyone. Today we'll discuss about number system. So in number system, number 1, we have the set of natural numbers. Okay? And this set of natural numbers is represented by or denoted by capital N, the bold N. Okay? And the definition of N, as you know, it contains the element 1, 2, 3, 4, right? And I am writing this whole element. We have infinite numbers of element here. So I am writing this one within this curly bracket. Whenever something is represented by a curly bracket, it represents a set. I'm coming to the set later on. So let me try to help you to understand what are the number set we have. So number 2, we have the set of whole numbers, and it is denoted by W. Okay, and this W contains only one extra element, 0, of the natural numbers. Okay, so it contains the natural number set plus one extra 0. Then we say W is a whole number set. Then number 3, we have integer set. This integer set, sometimes they used to write Z, or sometimes they used to write I also. Okay, the bold I, the bold one. So next, what we have, the integer set, and this integer set is represented by Z and defined by this whole number set here, right? We have the whole number set here from 0 to 1, 2, 3, 4. This one our whole number set. Okay, and extra element what we have the all negative numbers of the whole number set, or you can say the negative numbers of the natural number set. So we have this one, and number 4, we have rational number, and already you know the rational number is denoted by P by Q, right? Any rational number can be represented by P by Q, and the collection of all rational numbers are denoted by Q, this capital Q. Okay, and remember, whenever you have P by Q, is Q not equals to 0, and P comma Q belongs to the integer set. That means what I want to say here, whenever you write P by 1, okay, here 1 is not equals to 0, then this set, whatever you put here, the P, where P belongs? P belongs to this set. P can take any number here from this whole number, whole integer set. You can take -1, 0, 1, 2, 3, 4, -4, you see. So whatever you put the value of P from here integer set, ultimately this will give you the integer set. Okay, remember this one. Now we can have lots of infinite numbers also there, which can be write as say 2 by 3, then 5 by 7, then 3, then -4. These all numbers are belongs to the set Q. Okay, now come to the set where the element doesn't contain in Q, and these irrational numbers, already know what are the irrational numbers, the numbers which are non-repeating and non-terminating. That's it, that numbers are called irrational numbers. And you know about irrational numbers, what was that? The irrational numbers is defined by Q to the power C, and we write this one as a C is representing complement, COMPLEMENT complement of whom? Of the rational number set. Okay, and it is denoted by x such that x not belongs to q. What is belongs to? Belongs to, say you have a number set a, then we write 1, 2, 3. How many elements are there? 3, right? So we can say 2 belongs to, this symbol is called belongs to capital A, but this 4 does not belongs to capital A. So that's why I am writing here those elements are not contained in Q, right? So these are the elements. X says that X not belongs to Q. So what will be the element here? It can contain whatever, root over 3, root over 2, you see, dot 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 dot. Okay, this root over 3, root over 2 does not contain in Q, right? Because root over 3, root over 2 are the elements in the irrational number. That's why I am writing X not belongs to Q. This X our root over 3, this X our root over 2, and this root over 3 is not contained in Q. Okay. Next, what we have? We have the set real number. Okay. And the set of real number contains all the elements of the rational number as well as irrational number. This set of real numbers is represented by capital R and it contains all the elements of Q and Q to the power C. That means complement of Q, irrational numbers. And lastly, the bigger one in class 11 you will get is a complex number. And this complex number can be represented as a plus iota b, such that a comma b belongs to R. This a comma b belongs to R means it can take any value from the R. And this I as read as we say this one as iota. A plus b iota. Okay. Next, I try to draw the sets through which you can learn, or you can say compare what are these sets all about. Okay, so the first is the natural number set, right? And we know the natural number set can be written as 1, 2, 3, 4, right, dot dot dot. We can have infinite numbers of elements here, 7, 8, 9, okay, dot dot dot, infinite numbers of elements. Next, what we have the integer set. Now we have the whole number set. And what is the whole number set? Whole number set contains extra 0 here, right? So this whole number set, this whole this one, the whole set. Okay, this whole set is the whole number set. 1, 2, 3, 4 dot all positive numbers plus this 0. Next, what we have? We have integer set. Okay, and this integer set is represented by z, or I told you that it can be represented by I also. And what it contains? It contains all the negative values, right? Plus all these elements, this one plus this one. That means the integer set will be this one, whole one. Okay. Next, we have what we have? Next, we have rational number, and rational number is represented by Q. Already I told you what is Q here. The Q is the element or set where it contains all these elements plus these numbers. Okay. Now after that I told you that about Q complement, right? And I represent this one as a Q complement as the set of irrational number set. And what we write this one? We write this one as pi, then root over 2, root over 3, e lots of elements will be there. Here also you will have infinite numbers of elements will be there. Okay, so you see these numbers are not belongs to this Q. This number are not belongs to this Q set. Okay, that's why I have written there X such that those X, these are X, where this X does not belongs to whom? This Q. Correct? And what is Q here? Here. Do we have here pi? We don't have, right? That's why I am written X such that X does not belongs to Q. Whatever may be the elements here in Q, okay, it will not contain here, and this set, whatever may the element is there, it will not be in Q set. They are different. That's why I am representing this one is differently. Now, already you have known about this Q complement. Then after that, we have the real number set. What will be the real number set? The whole green one. What will be the number? Whatever may be the number here, this whole one will be our real number set. Okay, so you can say this whole, this one, whole. Okay, whole part is the real number set. This green part. Next, what we have now? We have after that a complex number. And what is the complex number? The complex number is C here. We represent it by C, and the yellow shade, now whatever is there inside that yellow, this will be your complex number. And what will be the element look like this one, 2 plus 3i, or iota, or minus 1 plus 2 iota. These are the elements. The complex number not only contains this whole element plus this element also, the yellow portion, the whole portion. Okay, not the white portion, there is no element here, but the yellow portion plus whatever is contained inside this set. Okay, so go through this video. If you have any doubt, then ask me. Okay, if you don't understand at once, try to view it again, then probably you will be able to understand it. Okay, thank you.